Okay, so we're in 2.5. And we're going to be talking about the rest of this kind of thing here. So absolutely. So here goes a couple of things. So last time that we were together, we talked about exponents, and then we were talking a little bit about negative exponents because that's what this whole lesson is about. Who remembers what a negative exponent implies? Who remembers what a negative exponent implies? What does a negative exponent imply? Sorry, I'm just grabbing my sheet. Yes, very good. It means dividing, Miss Johnson. A negative exponent means to divide, that you're going to be dividing by that many factors. Very, very good. Okay, so when I see this negative, I don't think negative answers. Remember, we talked about that. It doesn't mean a negative answer. Okay, so if you're part of that, that misconceived, they tricked you, they got you, no problem. Just move forward with it. Like, oh, you're not going to get me again. You're not going to get me again. But ooh, I like this. So someone said in the chat, and I'm just going to copy it. Since negative, and this is one of the things that you guys should be doing in terms of math, is kind of like finding patterns that make sense to you. So I'll tell you some of the patterns that make sense to me. But if you don't make your own patterns, then they won't make any sense. So someone in the chat said this. Let's make it smaller. Someone said, hey, Ms. Johnson, since negative is opposite of positive and positive is multiplying, right? 3 to the 4th is 3 times 3 times 3 times 3. Negative must be dividing. So this is how someone is making sense of this on their own, right? So your making sense of it is going to look completely different because you don't have this person's brain. But I like this. So they're pairing things, right? They're pairing and they're making things opposing each other. So it's negative is opposite of positive. Positive means to multiply, multiply, multiply. Then negative must mean divide, 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 which is right here. 2 to the negative third means 2 times 2 times 2, just on the bottom, on the division bar. Okay, very good. So then we were supposed to come up with this. It says to come up with 2 different answers for this. We are already kind of like moving for this. So I want to see what you guys have for this. And so I didn't open my Desmos yet. So go ahead and tell me what you think about this first answer. 3 squared times 3 to the negative second. What would that be? Yeah, someone says, Ms. Johnson, so I think it's 3 to the 0 because of this property right here where it says, oh, you can't see it, where it says something to the something and something to the something, same bases, and then you add the exponents. Okay, and then you add the exponents. Very good. So yes, that is true. Would you be able to show me a different way? Because they asked for 2 different ways to tell me this. 2 different ways. Yes, because we add the exponents. Perfect, perfect. Okay, so yes, so this way here was because 3 to the 2 minus 2 is 3 to the 0. Very good. Another way to come up with this answer, another way to come up with the answer is going back to the definition like we did over here. So let me scoot this over like we did over here. So go back to your definition or tell me what the negative exponent means. So that's one way. No matter which way you go, you're trying to make sure and verify that your answers are still exactly the same. Here's my second way. What does 3 squared actually mean? What does 3 squared actually mean? What does 3 squared actually mean? No, squared. There's only 2 of them. Very good. 3 times 3. Very good. Good job. And don't be bad. If you're making mistakes on this, making mistakes means that you're trying. Am I right? So that's 3 times 3, right? Very good. And what does, very good. Thanks for correcting yourself. Awesome work there. What about 3 to the negative second? What did we just say that that negative exponent means? What does that actually mean? What does that negative exponent actually mean? Yes, it means dividing. Very good. So if I'm dividing, so where do I put those 3's then? Where do I put those 3's? Someone keeps putting a -3. Is that 3 negative? Look very carefully. Is that 3 negative? Everyone says what? No, it's not. So no more -3's, because remember, negative exponents do not mean negative answers. So you want me to divide by 3? Yes, I want you to divide by 3. So go like this and divide by 3. How many 3's do you want me to divide by? How many 3's do you want me to divide by? How many 3's? Yes. So 1, 2. Oops, I put a 2. I meant 3. I was counting. So that's what you want me to do? Yes. Oh, okay. Well, what goes on the top, Miss Johnson? What goes up here? Okay, here's a little quick check. Why do I only have 1, 2, 3, 4, 5, 6, 7, 8, 9? Why do I only have 9 people participating right now? What's up? What's up with that? Yeah, I keep track. It's pretty creepy, right? So it's a 1 that goes on top. So Miss Johnson, where did this 1 come from? So this is my little side. When I have this X right here, so pretend I have an X. This is weird. Are you ready? Does anybody see or does anybody know where any of the invisible ones are? Where's an invisible 1 on this X? It's just a normal X. Yep, the denominator. So I'm going to put everything that's invisible that I don't have to write in my glitter pen. I pretend that my glitter pen is like, you guys get to see what it looks like. Okay, everyone stop really quick. Everyone pause. Think about the grade that you want. Okay, now think about the characteristics and the behavior of people who have that grade. Okay, now do what they are doing. So if you say, Miss Johnson, I really want to get an A, okay, then do the things that people get A's do. Let me just say it right now. Most of the people who have A's they're not quiet in the chat right now. So for those of you who are like, I'm scared, I don't want to fail this class, then do something about it. Because I'm going to bring it back to this day. I'm going to be like, yeah, on April 17th, you didn't participate. Yeah, I got it like that. That's what I'm going to do. Okay, here's my glittery 1. Where's more 1's? Where are more 1's? There's at least a couple more 1's that I wanted. Where is the 1? Where is 1? So X divided by 1 is X. Yes. Where are more invisible 1's on here? Yeah, on the X. No, X does not equal to 1. That's not what we're doing. How many X's do you have right here? Good. Where does that 1 go? There's 1 X. Where does that 1 go? Yeah, so someone says, Miss Johnson, X to the first. That's another 1. It's invisible. That's why I'm drawing it in my glitter pen, so you can see it. Okay. Wait, how many X's are there? 1. You would say there's 1 X, correct? So where does the other 1 go? There's 1 more 1. Can you guys do PEMDAS for me really quick? Go through PEMDAS and put the ones and see if it changes the value. So parentheses, that doesn't make sense, Ms. Johnson. Noah got our exponent, x to the first. What comes next? PE. No, x plus 1 would change the value of this. Yeah, multiplication. Do you have multiplication here yet? No. So where do I put the 1? It's so obvious you guys aren't doing it here. How many x's are there? You said 1. 1 what? 1, yes. 1x. Very good. Okay, these are all the ones that appear and disappear as necessary. Does that make sense? They appear and disappear as necessary. Right now, this one, the multiplication one, appeared because I needed it to. It appeared because I needed it to. Does that make sense? Okay, so then let's simplify this. What's 3 times 3 divided by 3 times 3? What's 3 times 3 divided by 3 times 3? Yeah, it's just the number 1. Miss Johnson, you over here got 3 to the 0, and over here you got the number 1. Miss Johnson, those aren't the same, or are they? Are they the same or no? Is 1 the same as 3 to the 0? Is 1 the same as 3 to the 0? Yes. Okay, we talked about this earlier. Anything to the 0 is 1 except for 0. Anything to the 0 is 1. So if you said no, it's not, you better learn this. Get it in your head. Yes, I'm so glad that you made that mistake in front of everybody, because now you can get it right. Okay, so 3 to the 0, Miss Johnson, is just equal to 1. Yeah. So you're saying so far, Miss Johnson, this is the same as this? Exactly. Okay, if you want to do one more way, just so that you guys are all seeing all the different ways, 3 squared times 3 to the negative second is the same as, what does a negative exponent actually mean? You said to divide. So the next line that I would do is I go 3 squared times, actually not times. I could put it there, it doesn't matter. Okay. The next line is this, because this became this, right? This is this. Hey, what's anything divided by itself as long as it's not 0? What's anything divided by itself? Yeah, it's 1. So Miss Johnson, you got it, like, again, you got 1, 1, and 1. They're all the same. Yes. So when it tells you to use a different way, right, it says, when you finish, use another method to solve. They're training you to look for multiple ways of solving the same problem. Okay, now that your brains are all warmed up, I need you to try number 7 on your own. Pause the video, try number 7 on your own. Okay, so here we go. So you all did this. I saw a couple of you have already the right answer. There's a couple ways to do it. I'm only going to use one way, just so that we can move forward. Okay, so 3 squared time divided by 3 to the negative first. Okay, so the 3 squared part right now, I'm just going to leave it alone. Actually, you know what? So since you guys were talking about division in this, in the conversation earlier, in between these times, I'm not going to use the rewriting this as a fraction. I'm going to use this one right here, because this, do you see how this looks like this? So what did we do to our exponents? What did we do to our exponents? So if we're dividing and the bases are the same, what do we do with our exponents? Yeah, we just subtract it. Some of you said some gnarly things. That's not correct, and that's okay. But no, look, it says it. A to the m divided by a to the n equals a to the m what? Say this with me. A to the m, what did you all say? Oh, minus n. Minus. Okay, so you want me to write that? Yeah. So here we go. So it goes equals 2. Sorry, I highlighted. Ignore that highlighting. Equals 2 a, which in this case, what's our a? What is our a? In this case, what is our a? For this problem here, what is our a? Play matching. Very good. It's 3. Okay. And then you want me to write a 3 right there, Ms. Johnson? Yes, write a 3. Okay. And then you want me to take my exponents and what? Subtract them. Very good. So you want me to subtract them? Yes. So Ms. Johnson, subtraction, the order matters. Yeah. So we did upper minus lower. So go upper minus lower. Now, some people think, Ms. Johnson, you wrote 2 minuses. No, I didn't. This -1 came from here. And this 2 came from here. And I was just subtracting them. All right. So 2 minus -1. You guys all remember your integers. So that's just 3 to the third. It's just 3 to the third. Okay. Okay. And then some of you did do that division, so I will show you really quick. So 3 squared divided by 1/3. Some people say, hey, Ms. Johnson, you could divide by a fraction. You can divide by anything, right? But you can't divide by a 0, because then it'll give you a messed up thing. So when you divide by a fraction, do you guys all remember this? When you divide by a fraction, what are you actually doing? Multiplying by the, yeah, by the reciprocal. So if you take 1/3 and you reciprocal it, you flip it. So it's 3 squared times 3 over 1, right? Which is just 3 cubed. Look, I got the same exact answer. 3 cubed, 3 cubed. Okay, same exact answer. Same thing goes here. Same thing goes here. I picked at some of your answers and I saw a couple of you confused here. So that I only deal with one thing at a time because that's what makes sense to me. Do you see this 5 to the -2? What is he telling me? What is that 5 to the -2 telling me? Yeah, I want to be in the division spot. That negative says, hey, I'm dividing. So this guy turns into this guy, right? Ms. Johnson, what do you do with the 5 cubed? Do you put it to the top? No, because it didn't say to. So do you want me to just leave it? Yeah, just leave it. So do times 5 cubed. So again, this guy, oops, wrong color, this guy here, this guy here. Guess who is going to make an appearance right here, coming back from invisibility world? What number should I put on top? Exactly, a 1, right? So what's my total answer here? What do I put as my final answer? Very good. I've got more people participating. Good. You participate to get all the wrong stuff out now. No, my big answer, my total answer. Oh, I don't want to multiply. Don't multiply 5 times 5 to get 25. Leave your answers with exponents. It's fine. But with positive exponents, right? So my final answer for this one would just be 1 over 5 to the 5th. Someone said, Ms. Johnson, can I write 5 to the -5th as the answer? Yeah, I guess so. It says apply the division rule to the expressions. Oh, that's what they wanted. Yeah, so 5 to the -5th actually works. So they wanted you to actually use this rule right here to subtract it. So let's see if that's true. So if I actually use this subtraction rule, should I still get the same answer? Right? Should I still get the same answer? So then here, according to this, what is my A here? What is my A here in this case? I'm doing this a second way right here. Yeah, it's just 5. And then what do you do with your exponents when you subtract? Say it with me. A to the m, say it. Minus n. Very good. Minus. So we're subtracting, Miss Johnson? Yes. So what I like to do is I like to put a little minus sign in there. And then I like to put the top exponent, which is a -2 minus 3. So my final answer, 5 to the -5th. And then you're like mad at me because, hey, Miss Johnson, are these two the same? Are these two the same? Look, 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 look. I've lost some people. Hey, look, are these two the same? One person says yes. Yeah, these are the same. So you need to train your brain, okay? You need to train your brain to see these as the same. So if I took like, I don't know, like your 3rd grade little brother and said, hey, do these look the same? Guaranteed they're going to be like, no, right? So just like a $20 bill to like maybe a 3-year-old, a $20 bill and two $10 bills to a 3-year-old, they don't look, they're like, they don't look the same. But me and you know these values are the same. So these are synonyms of each other. So some people call me Mrs. Johnson. Other people call me by my first name. My children call me mom. The value is the same. So you got to train your brain to say these two things are the same. Much like you would as like 2 times 2 and 4, even though they look different, they are the same. No, Alfred, you missed something. Look at that. Look, Alfred, what did you miss? You missed one small thing. Yeah, Alfred, very good. I love when you guys make mistakes. I love it even more when you correct those mistakes. No, don't be sorry. I think it was just you typing fast. So when you make mistakes and you fix them, that's when you've learned, not when you make mistakes. So don't go out there and be like, 2 times 2 is 100. Look, I made a mistake, I learned. No, it's you fixing the mistake. All right, let's continue. So now apply the power rule. So the power rule looks like this. It's right here. It's this guy. So you have like, look at this guy and then look at this guy and tell me what happened. Okay. What happened to our exponents from here to here? What happened to our exponents from here to here? Boom. Someone says, Miss Johnson, they're being multiplied. Exactly. So when it's a power of a power, so everyone say power of a power, power of a power. Doesn't that sound like I don't know, some like super, yes, like Power Rangers. When you have a power of a power, right? So what they're saying is you have an exponent inside the parentheses and then you have an exponent outside the parentheses. That's what they're saying. When you have the power of the power, they want you to multiply the exponents. Power of the power. Okay, can you pause right now? Try this. Just use the straight rule. Yes, exponent rules are Power Rangers. Exactly. All right, pause it. All right, so if you're using the power of the power of the power of the power rule, okay, sorry, the power rule, right? If you're doing the power of the power rule, this is how it works. You take your base, and then you multiply your exponents. So 3 times -2, which is just 3 to the -6. They don't even want you to do anything with that -6. They don't want you to like divide him or anything like that. They just want you to leave him like this. Okay. I'm reading the chat. Okay. The other thing, and then it says use another method. So I'm going to use another method for this just to show you that this actually legit works, okay? And if you just base this off of your definitions. So do you see this -2 right here? What does this -2 tell this thing to do? Wait, pause on the chat. Stay in power of the power rule. Come back. I know, we just started talking about like food. Okay, back over here. So what does this -2 actually mean? What do exponents that have negatives actually mean? Yes. Wait, you want me to put that whole thing on the bottom? Yeah, take that whole thing and put it on the bottom. Twice. Take that whole thing, 3 cubed, put it on the bottom twice. So what does 3 cubed squared mean? Remember the power of the power? You're just going to multiply. So we get 1 over 3 to the 6th. So my question to you, is this the same as this? Is this the same as this? So Noah says, yeah. Ooh, a bunch of people say yes. Okay, very good. So if you see this and you're like, yeah, Miss Johnson, it's starting to remind me that they are the same, then you're moving towards the understanding that I'm pushing you to. Okay, let's do this one. Miss Johnson, the power of the power rule, don't worry, I know how to do this. All I do is I take my base. Oops, I'm still in highlighter land. I take my base. And then I take my exponents and I multiply them, right? Power of a power, multiply. -1 times -2. Ms. Johnson, that's just 5 squared. Exactly. Ms. Johnson, can we use these rules during our test? Yes. But hopefully, remember what I say, hopefully you've learned them, you've used them so much that they make sense to you, that you're only accessing them to make sure and verify that you're right. Okay. All right.